Okay, we've been looking at reactions between metals. Last term you looked at reactions between metals and dissolved salts. We've also looked this term, most of us, at reactions between metals and acids. Today we're going to think about the reactions between metals and water. So, what would be our expectations? Somebody put a hand up and answer me. Yes. Okay, if you've got a reaction between metal and water, what do you think is going to be formed? Think about displacement reactions. Well, what metal would give you rust? Iron, all right. And what? Think again. And what metal, what will be the other product? So we're going to get the oxide of the metal, and the other product will be? Hydrogen, yes. Okay, good. Right, okay. I'm going to demonstrate here the reaction between magnesium ribbon and steam. So all we've got in this boiling tube is a coil of magnesium ribbon and some rock wool, mineral wool, which has been soaked with water. Okay, this is a potentially quite exciting reaction. So, okay, the first thing I need to do is actually to heat the magnesium so that when the steam hits it, it does actually react. Okay, and as we said, we're anticipating that we're going to get hydrogen formed, so I should be able to get a hydrogen flame burning at the end of the little tube. It does take a few minutes for the magnesium to get hot enough, but let's start now seeing whether we're going to get a reaction. You can see the water's boiling and something's beginning to happen. I can see things beginning to happen on my side. There you can see steam coming out, so that's good. We've got plenty of steam. Is the magnesium going to react? Come on, do it for me. It always takes longer than you think it's going to start reacting. Yes, because we're using Google Hangouts, so we're directly connected to the other two labs. No, because we've only got one fume cupboard. Yeah, it does take a bit of time to get going, but once it gets going, there we go. And there's the hydrogen flame, which I'm now going to blow out before we get it sucking back into the boiling tube, because otherwise we get... Okay, so you can see a really sorry, I've just shut the sound off. You can see a really vigorous reaction taking place between the steam and the magnesium. Okay, we've got a lot of white powder forming in there, which is a white powder. And we've got magnesium and steam reacting, so what's the white powder going to be? Magnesium. Somebody said it over there. Magnesium oxide, yes. So we know magnesium oxide is a white powder. It's still glowing. You can see how hot the reaction is because look at what's happened to the test tube. All right, and this is a Pyrex test tube. This is a heat-proof test tube. So there's an enormous amount of heat in that reaction. Okay, so that's the reaction between magnesium and steam. Okay, more reactive metals, I need to be very careful how I move this. because that test tube is now rather in. Yes. Yes. No, it reacted. The magnesium ribbon reacted with the steam. Okay, for the benefit of the other classes, the question was what happened to the magnesium ribbon. So the magnesium ribbon has actually reacted with the steam. Okay, yes? It's magnesium oxide, isn't it? Yeah. Okay, the next set of reactions is between more reactive metals and water. And I need to just adjust the camera position so that you can see what's happening there. Okay, I've got 4 reactive metals. I've got calcium, sodium, lithium, and potassium. Okay, I'm going to start with calcium. And I'm going to put gloves on because some of these metals are so reactive that if they actually come into contact with your skin, they could give you chemical burns. So, some gloves. I hate putting these things on. Yep. I beg your pardon? Well, you tell me what you'll be anticipating. You've got a metal reacting with water.
So what's this one? Calcium?
This is calcium that's going to be the first one. Okay, calcium metal granules. Okay, so if we've got a metal reacting with water, what are we likely to have given off? Yes, I can see some hands up in the other classrooms. Go on then. Who's that in the front row? Next to... yeah, Hugh. All right, behind Hugh. I can't see who it is because the image isn't big enough. Yeah, I can't actually hear them. Okay. What are we going to get given off? Metal and water. Think. Oh, come on, boys. What did we get given off when you had steam and metal? No, what was given off? Hydrogen. Thank you. So what's going to get given off when... Right, thank you. Hydrogen. Right. Okay, so... Right, that's the granules of calcium. Oops, they're the granules of calcium, okay? So it's a metal, okay, small granules, and I'm going to put that into the water, and then I'm going to try and catch some of the gas coming off with the test tube. Okay, you can see it's fizzing, possibly you can't see it's fizzing terribly clearly. Okay, you can see it's fizzing, and I'm going to collect the gas there. Yeah, there's water inside the test tube. You can see a white cloudy material forming in the water as well. Okay. Okay, so I've now got a test tube full of what we think might be hydrogen. So, how am I going to test for hydrogen? The squeaky pop test. Okay, Mr. Foley's class I think hasn't seen this yet, but so there's the test tube. Was that a squeaky pop? Yeah. Yes. Okay. So we've got hydrogen forming. Calcium doesn't turn into hydrogen. Calcium reacts with water to produce hydrogen. Okay, let's get our terminology right. Okay, can you see that the water is actually very cloudy now? Can you see that? Yeah, okay, let's move it this way a bit. Okay, so what do we think the cloudiness in the water is? Calcium oxide, yes, calcium oxide, which isn't terribly soluble. It is slightly soluble. So if I put some lime water in, what would we expect? What colour would we expect it to go? Being no, it. Well, you're going to be predicting it's going to be acidic. It'll be alkaline, so it's going to go bluey purple. Okay, so all right, so that's slightly the blue side of green. All right, so mildly alkaline. Okay, a pH, what, round about 9, something like that. Okay. Yeah, it's gone about a sort of bluish colour. That was universal indicator being added to the liquid in the bowl, and that's come up with a pH of around about 9. So yes, what we've got in the bowl now is lime water, because lime water is calcium hydroxide solution. Yeah? Okay, I'm now going to empty this out and just wait for a moment because it hasn't quite finished reacting. And the authorities tend not to like you pouring hydrogen down the drains or reactive metals reacting with water down the drains. They tend to think it's sort of going to be not very clever. No, water is hydrogen oxide, isn't it? Right.
So it was calcium oxide.
Yes, which then reacted with the water to form calcium hydroxide solution. Okay. Let me get some fresh water, but not from that tap because it's break all the computer. You can always edit it. You're all right.
What metal is this stuff?
Right, next I'm going to use. Potassium.
What's the next one?
Okay, so the next reaction will be between potassium and water. Okay, and right, potassium is so reactive a metal that it's actually kept under paraffin. Yes. So I need to extract it from its jar. There we are. So I'm going to turn the Johnson off as well. So there we have the potassium in the jar. I'll get a piece out. I'll try and get a piece out. Those tongs are the wrong shape. Straight ones. Okay. So there's the potassium. Okay. Can you? It's actually. Can you see? I can squeeze it. It's a little bit like putty. I'm only going to use a very small quantity of it. Paraffin. You'll see why it isn't kept in water in a minute. Put this back. Right, so we've got a small piece of potassium. Let me get the camera so that we can see. So, small piece of potassium you can see, which I'm going to drop into the water. And you can see it's burning with a lilac flame. Okay, the potassium, you see it burns with a lilac flame. There is so much heat generated that the potassium actually starts to burn. Okay?
Was the gas like?
Yes. Lilac colored flame. What do you think? Right, can you still hear me in the other two labs over the noise of the fan? Yes? Miss Jones's lab, can you still hear me? Okay, good. I had to switch the fan on because the potassium produces clouds of potassium oxide. Right, let's try that. Ugh. Sorry, I'm struggling to get a bit of sodium out now. There we go. So there we've got some sodium. Again, a sort of grey, putty-coloured metal. Again, very soft. You can see I can squeeze it quite easily. Okay, so small piece of sodium, all right, and again I'm going to drop this into the water, watch what happens. It's sodium oxide powder, which is getting moved up in the, okay, which is being carried by the, and it was the same with the lithium. It was lithium oxide powder, and I got a face full of it, which didn't do me any good. That's why I had to switch the pan off. Yeah, sorry, potassium. Potassium. That's more of the lithium. The gas is hydrogen. The fumes are the oxides. But it's not a gas, it's a very, very fine powder being carried in the air currents. Yeah, it's even finer than that. Okay, so not as violent a reaction, not as much heat generated. You do sometimes get the sodium catching fire, it produces an orange flame, but this time it didn't. So, but a similar reaction, I don't know whether you could hear it fizzing, but it was fizzing. There was enough heat to melt the metal, and it's getting about on the surface as the hydrogen is released underneath it and pushes it around. Okay, the last metal that I've got is lithium. So again, same procedure. Again, lithium is stored under paraffin. Sorry, that's the alarm on the fume cupboard telling me that right. It's the alarm on the fume cupboard telling me that the airflow isn't working properly. So there's the lithium, a slightly darker coloured metal. Okay, and again I shall take a small piece off. These metals are all so soft that I'm cutting them with a knife. The lithium is the least soft of them, but is most difficult to cut with a knife. Yes. Yeah, well, we only need a few minutes. Okay, so again, you can see the cut surface is shiny. All right, where it's been in contact with the paraffin, it's a little more dull. And again, same procedure. Sorry, where are we? Oh yes, just there. Okay, it's fizzing. It's not as clear. You can see the white fumes coming off it. That's the lithium oxide powder being carried up in the air currents. Okay. Right, and again, not quite enough heat there to even melt the lithium, but still getting it moving around. So again, not quite as violent a reaction. Okay, Occasionally, yeah, the question was, will it sometimes produce a flame? Occasionally with lithium, yes, but nowhere near as frequently as sodium. When it will produce a flame is if the metal gets stuck against the side of the container because of surface tension of the water, then the heat can't dissipate and so it actually burns. Now you're asking, lithium. I'll have to look it up. Okay. All right. Okay. Thank you very much. Thank you, Mr. Foley's class. Thank you, Miss Jones's class. I am going off air.